and welcome to another video in the OpenComputer tutorial series for version 1.3. My name is Lord Yoda and I'm here with Sangar, the lead developer of OpenComputers, and Darka Total, our cameraman. In this video, we want to take an in-depth look at components, and this time a more detailed look at, well, examples of components. So yeah, we have seen in the last video how basically to use them. Now we want to, get them really to do something.
Yeah, so basically the idea is to have a look at some of the actual components built into OpenComputers and see how to use them. So the first thing we'll have a look at are the Redstone Cards and the Redstone I/O block. So the main idea here is to demonstrate that components for the computer are, well, they're just that. So the computer doesn't differentiate between block components and item components. So two things, as mentioned, there are two tiers for the Redstone card. The basic one, so the tier 1 card, can only interact with vanilla Redstone, so it can output and read basic analog Redstone signals. And the tier 2 card can interact with other mods, Redstone extensions such as bundled cables from Projector. So let's start with the simpler Redstone card and just put it into your computer, and as soon as you do this, the computer can interact with Redstone that is located next to it. So it can output and read Redstone signals from the 6 blocks directly adjacent to it. So not diagonally, but in front of it, left, right, back, top, and bottom. So now let's get some redstone and some things so we actually see what happens. So the first thing we see is, if we have the redstone card in the computer, that it appears in the list of components. So in this case, we only have one component, one redstone component, so we can simply use the primary system for the components and address it via component.redstone. And if we do this, we see a list of functions, and this is the basic way to interact with redstone signals. So the input on a specific side, setting the output on a specific side, and checking what the current output is on a given side. And for the sides, as you see, these are numbers. So to have this a little easier to read in your code, there's an API that's called sides, and this is basically just a mapping of names to numbers. So for example, if I say I want the front side, this will give me the correct number for the front side for these API calls, for example.
And
so now,
as I remember, the sides are as seen from the computer.
Exactly. So this we will see in a moment. So as opposed to that certain other computer mod where the orientation is basically from when you look at the computer from the front. So if I'd say left, that would be on the left here. But in OpenComputers, it's orientated from the facing of the computer. Because, well, this is the only fixed way. If I'd open the GUI from the back, then the left would be on the wrong side. But if I know that it's based on the facing of the computer, which is this way, then left is always that and right is always that. So if I go ahead and say component.redstone.set output on sides right to 15, then I'll see this lights up and there's some signal here. So this is now active as opposed to, say, the front. And if I now check...
Yeah, remember redstone values go from 0 to 15. Also, that's just basic vanilla. And yeah, basically it decreases by 1 each block it travels by.
Exactly. So if I, let's say, if I pull this a little further here and come back to the front, and then check the input on the front side, which I do via the input method, so get input on sides front in this case, I see there's a remaining signal strength of 5 left. So if I change the output to 10, that should be 0 exactly. And yeah, exactly. So for vanilla redstone, as mentioned, the valid range for numbers is 0 to 15, with 15 being the strongest signal. It's probably even going to yell at me if I take... No, it doesn't, but it won't change anything, so... If I get the output, it's saved as 16, but it's still just the output of 15, so if I get the front one, it's still only 5. The reason why this allows larger values is for certain mods which have their own redstone transmission capabilities, such as Project Red. These cables usually allow for stronger signals. So Project Red and Red Logic, if I'm not mistaken, have a value range of 0 to 255. So that's why you can insert larger values. So if I replace the redstone powder here with cables, these will also light up because they are compatible with vanilla redstone. So, oops, and I do this, then the input on the front is a lot stronger because it doesn't decrease by 1 per block, but 1 per, every 16 blocks, I believe. So yeah, so you can have stronger values running through these cables if you like. It's also a... oh right, and it's converted back. So redstone is a little confusing when using it with several mods, because pretty much every redstone mod behaves slightly differently in certain cases. So what can happen is that if you say something like, okay, I put the output to some low value that should just arrive, but it can happen that due to conversion between mods, nothing arrives at the front. So if you use some cables from, I don't know, other redstone mods, just try higher values if you don't see any output arriving. Okay, so that's for the basic redstone. Another way to interact with redstone besides the cards is, as mentioned, via the Redstone I/O block. So this is basically just an external redstone card, so to say, that can be placed anywhere in the world. So if I take out the redstone card from the computer and place down the Redstone I/O block instead, in a way that is connected to the computer, so instead of directly next to it, I could also place it one further away and get a cable from somewhere. There we go. And connect it like this. Then we'll also see that there's still a redstone component, but in this case it's now the block here. So if we check the address, we see the D90 is the address of this component. So it's no longer the redstone card, it's the block, but the API is completely identical. So if I check what it looks like here, we'll see it's the basics of the other card, and the additional functions you see here are from the Tier 2 redstone card. So a Redstone I/O block is basically a stationary redstone card Tier 2. So this also allows us to demonstrate the bundled functionalities for other mods. So essentially it's the same as for the analog simple vanilla redstone, but it also takes a color value for the channel on which to send the signal, essentially. So let's say I have this bundled cable and some isolated cables, and connect those to the block, and then I take out these colored ones to split it up again, and just to be safe, put this there and get a lamp. Oh, actually, let's use the other one as input. So let's put a redstone torch here. So now, as you see, we have an input from the blue wire and an unset output for the green wire. And redstone blocks also use sites in the API. So as we see in the get bundled input method, for example, we have a site and the color to get the value for. And the sites for the blocks are absolute. So it's the world directions of Minecraft. So in this case, it's this direction, which if I check in the debug info is north. So I should be able to see some input, not component, redstone redstone get bundled input on sites north and color. There's also an API for the colors. Is it colors or color? I never know. Colors perhaps? Blue.
The int is color.
Well, yes, but that's just the variable name. So it's also site is also singular. It's just the name for a parameter. The API is called, I don't know, let's see in this computer what's in lib. It's colors, it's plural, okay. So this should now give us some value. Yes, it does. So here we see that there's some input. And this is some of the, well, inconsistency I mentioned earlier. So as we see for bundled cables, for example, it's not converted back to vanilla before it goes into the computer, so the full value range is kept, and therefore it's 250 and not 14 or 15. So that's just something to keep in mind when programming with Redstone. And if we go ahead and set the output, which we can see is set bundled output here, it also takes a site, a color, and the value to set the output to. Excuse me. So that would also be site north, and this would now be lime, I think. And let's set this to something large. And there we go. It lights up. So yeah, as you see, pretty simple, and it's the same way of getting your information for how the methods are called and how to call them as demonstrated earlier. It's just some more concrete examples of how to use it. And as you also see, it behaves the same API-wise for the Redstone I/O block and for cards in the computer. So I think that pretty much captures it for Redstone. There's one more thing that is worth mentioning. As also demonstrated, some components generate events, and these can be pulled with the event.pull method. So the Redstone Cards and the Redstone I/O block generate an event called Redstone Changed, or just Redstone, I'm not sure, which you can basically wait for to see if some input value changes. So if I go ahead and say, okay, let's pull some Redstone event, so this value here, it doesn't have to be the exact name of the event you're listening for, it just has to be part of the name. So if I'm not sure how the event is actually called, I can just say, okay, let's just listen for some event that's called red something, which I can do here. And now if I remove this torch over here and thus change the input to the Redstone block, it should, in theory, give me an event. Exactly, and it is Redstone Changed after all, yes. And as usual, it's the name of the event, the component that triggered the event, and then some value. In this case, the value is the side on which the Redstone value changed, input or input changed. So this should be north. So I can check this the other way around too. So I can resolve the numbers to names, and that's, well, yeah, back is the same as north, if I remember correctly. Yep, it is. So this is the side on the component where the Redstone value changed. And that's pretty much all you need to know about Redstone components. There's one more thing that was added in a later version of OpenComputers, which is that, well, basically in 1.3, if I'm not mistaken, is that the Redstone Tier 2 cards support wireless Redstone of some mods. We won't cover this here, but it's pretty self-explaining, and if you use the general method of just having a look at the available methods in a component, you will just get a documentation of the methods you can use to change the wireless output on certain channels and read the current value of certain channels. So it's pretty simple to use. Alright, let's clean up a bit.
Good. So did you mention which mods we support for Redstone? I'm not sure.
Not this time, I think. So basically for bundled Redstone, we support RedLogic, Project Red, and MindFactory Reloaded, so the RedNet. And for wireless, we support the Wireless Redstone Chicken Bones edition and the Slime Void edition.
Okay.
I think that covers it, yes. Okay, so much for Redstone. Now some other components, also blocks in OpenComputers, are the Geolyzer and the motion sensor. And pretty much the same way as with the Redstone components, just connect them to the computer and they will show up in the components list. Should at least Geolyzer, yes.
Geolyzer,
and
yeah.
Then you can, get a list of the methods on the component this way, which in this case is just one method, which is the scan method. And this takes two coordinates which are relative to the block itself, so to the Geolyzer block. So 0, 0 is the column exactly inside the Geolyzer block, and the axes are the world coordinates of Minecraft. So which one is which one? This is the x-axis, and so if we take what one? This is smaller. Okay, so if we say -1, it would be in this block. Anyway, this method returns a table which contains values of hardness for the blocks in that column. So let's just call it Geolyzer scan 0, 0. And these values are, hardness values and with a little bit of noise, in the range of 32 blocks up and 32 blocks down, with the Geolyzer basically being in the middle of that table. And this you can use to, check if there's any blocks there at all, what kinds of blocks they might be, just to get a rough ballpark number based on their hardness, or stuff like that. So that's pretty simple, but you can do quite a few things with this. As shown in the update video for 1.3, you can, for example, generate height maps using the hologram component, hologram projector. So that's that, pretty simple. And the other one is the motion sensor, which has a few methods in its API, but those are usually not that interesting, which are just the sensitivities for the sensor, so when it triggers. What's more interesting is that this one generates events which allow you to know when some living entity moves nearby the block. So if I say event.pull, I think it's just motion, I'm not sure, let's see, yes. So this one gives me coordinates relative to the motion sensor plus the name of the entity that moved. So you could use this to track some entities in some area, for example, or react to entities entering an area, stuff like that. That's also pretty simple. So all you need to do for this is know how to pull events, which is, event.pull, and the name of the event, which is the motion event. And the sensitivity, just for completion's sake, is basically how far the entity has to move per second for the event to be triggered. So if the entity moves slower than this, it will not be triggered. If it moves faster, then it will. And the default is, I think, 0.5. Let's see. What was it? Motion sensor. Sensitivity. 0.4. Okay. So if any entity that is in range of the motion sensor, the range being 8 blocks, I believe, moves further than 0.4 blocks per second, an event will be generated for this entity. Alright, so that's that. As you may expect, there are a few more components in OpenComputers, of course, but we will cover these in more details in some later videos, in particular the network cards and, mostly the network cards. So, I think that's about it for this.
I think you wanted to mention
I wanted to mention something. Yes, exactly. That was what I wanted to mention. Thanks. Right. So these are all the components I just showed are built into OpenComputers. There's a companion mod for OpenComputers called OpenComponents, which allows you to interact with a lot of blocks from different mods. So what you do for that is you need an adapter block, which is this one here. This block can be placed next to some other blocks like the node block from vanilla Minecraft, and with OpenComponents from blocks from other mods like I don't know, Buildcraft and Industrial Craft and a lot of mods. There's also some general support for basic functionality such as inventories. So for example, if we had OpenComponents in this scenario, which I think we do not, I could place it next to this chest, and then I could interact with the chest, like checking how many items are in there, stuff like that. And since most mods implement the same functionality for inventories as the default chests, it's usually also possible to check inventories from other mods like that. So this is all supported out of the box if you install OpenComponents together with OpenComputers. All you then need to do is place the adapter next to the block you want to interact with. And as soon as you do, you will also get a component in the list of components, so it would appear in this list, so there would be an entry for inventory or chest.
Also, if you would have connected it, it didn't connect it.
Yeah, well, as I mentioned, it's not
just
in
to
any
make
way.
sure that nobody thinks it
Yes, it's not magical. Yes, you would need a cable here. Cable. Where'd the cables go? There's the cable. Yeah, so the adapter needs to be connected to the computer the same way as the components I just demonstrated need to be connected to the computer. And as soon as it is, then every supported block next to the adapter, so if let's say there's another chest over here and another chest over here, all of these three chests would then be accessible as components from this computer. And you see them show up in this list, and you could then interact with them the same way as you can with any other component. Yeah.
And yeah, to just put this again, we have not installed it right now, so
we can't demonstrate it right now, yes. But essentially, if you have it installed, you'd see the components for these three chests show up in this list, and you could interact with them like you can with any other component.
Okay.
Yep.
So basically, that's it for this time. I hope you now have a very good idea what you can do with the components, and be creative. And yeah, as we said, it's always the same idea behind this. If you don't know what you can do with a component, just take a look at its functions, and then you basically should know what to do. And yes, as always, keep in mind we are using version 1.3, so in a later version something might change. And yeah, as always, if problems appear, first take a look at the changelog, and if this doesn't help, yeah, go to the wiki and see if there is something, or also the forums, the IRC, and if all that doesn't help, you can create a new issue on GitHub.
Yeah.
Was this the correct order, or?
Yeah, I think that's pretty much it.
Okay. So,
sounds good.
Then that's it for this time. Thank you very much for watching, and until next time.
See you.